addition, according to Gotham analysis, Origin system can modulate some apoptosis-related genes. So next we study the cell death that is induced by orexia. We study cell death by tunnel assay that label the DNA strand break in the nucleus of apoptotic cells. And the table shows that orexia can induce cell death in a minority of monocytes, about 5 to 10% of monocytes were apoptotic at 1 or 2 days post-infection. We also studied the IL-1 beta release. The IL-1 beta is a cytokine that is associated with cascade 1 activation and cell death. The results show that live bacteria can induce IL-1 beta secretion from monocytes, and this response is quite specific to live bacteria as well. And the final objective of our study is to analyze the transcriptional response of patients with scrub typhus. We have a collaboration with a research team in Thailand who performed the transcriptional profile of patients with acute febrile illnesses. Objective is to determine a specific signature of patients, and we collect PBMC from normal subject and from the patient with various tropical diseases including malaria, murine typhus, dengue fever, and scrub typhus. We want to determine a specific signature that may be helpful in the diagnosis of scrub typhus. And the clustering analysis showed that the expression of the 65 transcript is quite distinct from the expression of other diseases. So, therefore, 65 transcript may be used as a molecular signature of scrub typhus. And we did explore in more detail. The clustering analysis showed that 5 of 4 genes were further selected because their expression was at least 2-fold higher than that of other diseases. So these 4 genes may be a candidate genes that may be helpful in the diagnosis of scrub typhus. And the expression of these 4 transcripts was confirmed by RT-PCR. And their expression will correlate with the microarray result. Then we compared our in vitro transcriptional profile of monocyte with the in vivo transcriptional profile of patients with scrub typhus. About 2,000 modulated genes from in vitro transcriptome were selected by SAM analysis. And these genes correspond to 1,600 modulated genes from patient data. And the clustering analysis between normal subject and patient with scrub typhus was performed. The clustering analysis showed that the expression pattern of the control and patient are quite different from each other. And this supports our in vitro transcriptional profile of monocytes. The upregulated expression of interferon-stimulated genes such as OAS, interferon-induced protein, and PML and M2 was observed in both monocytes stimulated by orexia and in patients with scrub typhus. In addition, interferon gamma was also upregulated in PBMC, suggesting that type 1 immune response is induced conclusion, firstly, circulating monocyte are targeted by Orichia's Scamacci. Orichia's Scamacci induce robust change in gene expression program and polarize monocyte toward M1 phenotype. This response was largely dependent on live bacteria in the cytosol, and this phenomenon is also observed in Rickettsia acari infection. So you can see that the response for Orichia and Rickettsia is quite similar. This highly inflammatory response may contribute to pathogenesis of Staph typhus, as monocytes are known to be involved in dissemination of Listeria monocytogenes and human CMV. So it's possible that Orichia may exploit M1 monocyte for its dissemination from the infected area in the skin to visceral organs. Type 1 interferon, interleukin 1 beta secretion and cell death are specific to live bacteria, and EQ bacteria cannot induce this response. Finally, type 1 or Th1 immune response and interferon-stimulated genes were observed in PBMC of patients, and these findings support our in vitro transcriptional profile of monocyte, because M1 monocyte is associated with the type 1 immune response.
Yes, Joe?
So, we have two questions. The first question concerns IL-1, interleukin 1 formation. Do you believe that Orientia activate the inflammasome?
Yes.
This is my first question. And my second question is more theoretical. How do you explain that M1 profile in fact is permissive for Orientia in contrast to what we knew before?
But the first question, in other cytosolic bacteria such as Listeria and Francisella can activate inflammasome and induce cell death and IL-1 beta secretion. The candidate again may be the cytosolic DNA or the product of lysosomal ligase such as cathepsin B that act as a danger signal and can activate the inflammasome. And it's possible that the cell death induced by origin may be the pyroptosis, and the pyroptosis can be observed in other infections such as Shigella, Salmonella, and Listeria, Francisella. And however, apoptosis may be involved because type 1 interferon are known to induce apoptosis-related genes such as PML, SARP1, TREL. So I think that there are two mechanisms that are involved in the cell death of monocyte. And the second question again.
So the second question is, how do we explain that by inducing N1 profile in monocytes, Orientia is able to survive and replicate? It's a kind of contradiction because N1 is a microdiscipline. So how do we explain?
Yes. I suggested that it's possible that human is an accidental host of Orichia. So infection in human may be associated with highly inflammatory response. The human may not a good host for Orichia, whereas the rodents are a reservoir host. And there are some data from mouse macrophage show that live bacteria induce lower inflammatory response than EQ bacteria, in contrast to human. So there may be some differences between mouse and human immune response. further study are required to answer this question.